Okay, so let's start continuing looking at our journey to cloud in the second video. I want you to start imagining cloud has been holded by a person who has two arms. One of his arms is automation, second arm is virtualization. These are pretty much the two pillars of cloud if you think about it. What does automation really do for us here? If you think about automation, what it really would do is it's going to make sure that it's automatically going to provision resources for you. So if you go to Amazon quickly, you want to go ahead and scale something from being less to more, we can do it. If I had less memory on a certain machine that I'm using, but I realize that instead of 8 gigs, I need 16 gigs, that's where the scaling comes in. And this can also be auto scaling, which means is at the time when it realizes that an application is using more, you go and provision more. So this does not have to be a person doing it. It can be done automatically. Configuration management, that can be all automated. You can have certain kind of monitoring and alerts, which means if something happens, for example, if the CPU is running high, then you send me an alert, and at the same time also add more from a scaling perspective. So they all kind of go hand in hand. Cost management this way, because if I'm using automation, it's keeping my cost in check. It's making sure that security and compliance is always there. Now, depending on what business you are running, if it's a retail store, you're running some applications which need to be PCI compliance, which means you're using credit cards here. Or if you're in hospital, you're dealing with patient records, then again, there is a different compliance for that. And last but not the least, you're always able to automate your operations, right? And now if I look at my second arm where it's virtualization here, see virtualization has, okay, I'm gonna basically, this is a definition of virtualization where I'm abstracting physical resources, which means now I have a piece of hardware that I can share by having different virtual machines on it. So this way, obviously, I'm able to efficiently utilize my resources. Another thing I can think of is dynamic scaling. Again, the example I gave before, scaling really means is dynamically depending on my needs. I can go up and down. I can sometimes increase the RAM, reduce the CPUs allocated to my now certain settings. You have to reboot your machine, so you have to remember that. Now, obviously, virtualization is getting more and more advanced, where you're also able to have two separate hardwares, and I can move one machine from one actual hardware to another by using something called as vMotion, which is supported by VMware. By the end user who's actually using the machine has no idea that's happened. So let's say his machine was sitting on server 1 somewhere, got moved to server 2 physically, and that person never knew about it. Obviously, there is virtualization in networks too. That's where you're able to isolate your environments by using those. Disaster recovery and redundancy. This is where I was giving you that example of vMotion, where if a certain hard drive or hardware or a certain server fails, you're seamlessly able to move that actual device from that physical hard drive. You can have templates and snapshot, which means I use a lot of Linux machines and I like to use my Ubuntu in a certain way, and this is what we use all the time. So you can have it as a template that every time you spin up a new Linux, it comes up exactly the way you want it. And snapshot means I can take snapshots of certain things, keep them in a certain way. If I make any changes to it and if it breaks, guess what? I can return to my snapshot. And obviously you can do security and isolation by using the virtual networks here, which we can talk about a little more in the future. So these are the few things that virtualization does for you, and then automation we kind of already looked at all these good features that they have, right? So this is, I feel, are the two arms of cloud. This is where the cloud really sits on when we talk about moving on. Another concept I want to bring up is sometimes virtualized solutions are thought to be as cloud solutions. They are not equal. Virtualization is a separate technique that the cloud leverages to develop those solutions which are cloud based. But virtualization doesn't mean it's a cloud solution. That's something very important to remember. Because when I'm talking about virtualization, it's just something that has been done forever. But then when we're talking cloud, cloud adds automation to it and certain more. And there are certain definitions that you need to have in your solution in order to be called a cloud solution. But before we do that, let's quickly look at what virtualization really is. So if I have this here, now think of this as this is a host server that are running on all this virtual machine. Now what's the basis of it? If you're looking at the basis of it, at the bottom of the chain, it is your standard hardware. This is where your usual hardware is. This is your hard drives, your CPU, your RAM. This is all that. And then on top of that, you have a hypervisor running, which is again a kind of a software that lets you install another OS on it and then run virtual machines on it. So this is a separate OS. And now you look at one hardware, which is able to run, in this case, 4 virtual machines. Now, if you really break down this hypervisor, there are, since we're talking hypervisor, there are 2 of these. So I can either have type 1 here, or I can have a type 2, right? Type 1, it runs directly on the hardware, and it basically is what cloud solutions are generally using. For example, for a type 1 would be the VMware ESXi, which is installed on directly piece of hardware. And then on top of that, you can manage it using vSphere, and then you can start adding more virtual machines to it. Type 2 example would be something that most of you must have used on your laptops, which is, again, I'm going to use VMware example. Let's say a VMware workstation or VMware player, right? This is where you're able to now this is installed on your Windows. And on top of that, you're going to be running different virtual machines or on your Mac or on your Linux. So it needs another operating system to run. This can run on bare metal. That's the main difference. Okay. Now, when we say what are the differences between these two solutions, as I mentioned, they are not. So what can I call a cloud solution then? So let's look at that very quickly. So if you want to call something a cloud solution, in that case, this is what I would do. So there is a NIST publication, which is 800-145. This is basically what defines a cloud. So I need to have, this is the publication, I need to have all these points satisfied. Once they are, then I'm a cloud solution. For example, it should be on-demand self-service. AWS, I can log on to their console and I can provision computing capabilities, right? I need to have a broad network access, which means it doesn't matter where I am. I could be at my home, my resources could be across the oceans. I still be able to access them. And then I have something called as resource pooling, which means is if I have multiple resources, I can pool those resources from multiple tenants. For example, I have 10 servers, and I can choose between those as needed. It should support rapid elasticity, which means as a customer, if I was running, say, 3 virtual machines, and if I want to run a 4th one, I should be easily able to scale up to another one or reduce from 3 to 2. Then I should have some sort of measurement, so I can automatically understand that how much is my usage, and I can optimize using those matrices that how is the cloud being utilized. So this is defined by the NIST definition, and this is the publication. So if you want to have more details, you can always go and check that out. Next I want to talk about is your actually cloud deployment models. So mainly we have a private cloud, we have public cloud, hybrid cloud, we have community cloud, and then we have multi-cloud. Private cloud means it's dedicated to a single organization. You're not sharing this with anybody else. Now, obviously, it's going to be much more costlier because it's only for you, so you're developing it for your own self. But then there might be some reasons why you're doing it, because maybe if you're like a financial organization or say something like a stocks where you don't want to share your data or you don't want to have any issues going on because of security or also because of compliance, then the most common one that we all, when people think cloud, generally the default one model is this one, which everybody knows about, which is the AWS, the Azure, the GCP, where like anybody, people like you and me, general public, can go and spin up based on what we need. Then hybrid cloud means I can combine both of these. I can have a bit of this, I can have some stuff here, and then I can have some stuff here. Is basically what gives you hybrid. Now community cloud also could be is okay, one organization doing this would be obviously super expensive. So how about we do this? If there are hospitals that can get together, instead of one hospital doing it, let's say okay, three of the hospitals in this area or in this province will go ahead and have their own cloud where they are putting the right amount of security they need, they have the right amount of resources, and this only belongs to them. They're not sharing this with anybody. And then multiple cloud means when I'm using multiple cloud, right? This might include when I'm trying to mix Azure with AWS. An example I'm giving you here is I'm using an AWS database for an Azure applications, trying to take advantage of multiple services, and they pretty much cover all the basics, but there might be a certain application or a certain service that AWS gives you better than the Azure, and vice versa is true. So if you want to pick up the best of both worlds, that's where you decide to go that way. Okay. One very key thing here is a lot of people do get confused about what is a difference between a private cloud. Is it equal to a private data center? The answer is no. See, if I'm saying private cloud, the moment this word cloud comes in, what we discussed before, that it needs to have a certain functions, or it needs to be able to have certain things. So it still needs to have that monitoring, automation, scalability, elasticity, all that has to come. Data center doesn't need to have all that. A private cloud is, think of that as a computing environment that is exclusively, I'm talking private here, for an entire organization, but it does offer all the scalability, flexibility, and the self-service capability similar to a public cloud model, which is a AWS. Now, when I say data center, a private data center refers to, think of it as a physical facility, again used, which has many servers and a lot of components, networking, storage, owned and operated by a single organization. It doesn't need to have any of the other stuff, scalability, flexibility. That does not need to happen. So that is why they are not same. So private cloud is not equal to private data center. The difference again is scalability, flexibility, and all the other stuff that usually comes with cloud. Okay. Now we kind of touched upon this in the last video, but this will go into a little more detail. We have something called as cloud service models. What are those? The most common ones that you'll hear are infrastructure as a service, platform as a service, software as a service, most common ones. But then don't forget that there are a whole bunch of advanced cloud services, and I have listed some of them here, but these are not limited to these. For example, you have Kubernetes as a service, container as a service, function as a service, and then no code as a service. And they have given you some examples here. These are your advanced services. Most common ones are going to be right here. And I'll talk about what those are and what are your, you can say, responsibilities here in a minute. But let me just go through this. So infrastructure as a service, which means I will give you a server and you can do whatever you want on it. Platform as a service means I'll give you a server and also install an OS on it and give you an environment to do something. Let's say if you were developing on it, so you can do all that. So example here would be an AWS Elastic Beanstalk or Google App Engine. There are a few examples here. And infrastructure as a service is just simply going to AWS EC2 or Google Compute to kind of go ahead and get what you need. Software as a service, on the other hand, is pretty much I'm giving you something that's ready. It's an application that's ready. We are consuming it. Examples would be Microsoft 365, Dropbox, Google Drive, Netflix. These are all software as a service. Now, certain advanced services that you have, Kubernetes as a service, you can use these, and they're not, if you're thinking that, okay, if I have this, what am I going to do with this? See, you have to understand that cloud is a whole service. You can take multiple services, combine these services to make a solution. That is where it's more of an architect role. That's where if you're a cloud architect, which means if a customer comes to you, says, this is an app or this is an application and this is what I'm trying to build. So you can say, okay, if you want to move to cloud, you'll need to have, for example, an AWS EC2 to run a certain application there. So you install your own OS and you run something here. And then you might need something like a service to manage all this. You need a certain function. So you don't really need to spin up a whole EC2 instance. Instead, you can use function as a service. So this is where you are saying that, okay, I'm going to combine all these services. At the end of the day, with this, I will be able to develop a solution. More to come on that. This is just to give an idea of what that looks like. As I said, most common models where we talked about the IaaS, which is infrastructure as a service, example would be Amazon EC2. What is managed by you versus what's managed by the AWS in this case? So AWS will manage this part here. This is what's managed by the AWS or Azure or Google, and this is going to be your responsibility. This falls under your responsibility. Okay. Now, this is for infrastructure as a service. When you go to platform as a service, something interesting happens is your responsibility kind of goes more now. Your responsibility goes less, and the provider's responsibility gets less. So you are only here. This is the provider now for platform as a service. Now, if I say, okay, what about software as a service? The only thing that you need to worry about is the data and the people here. This is everything managed by the provider in the Office 365 and the Dropbox for the examples I gave you before. Depending on what model you pick up, is it going to be infrastructure as a service, platform as a service, or software as a service, will change the responsibility of you and the provider, cloud provider, which I mean by that, and depending on what my requirement is as a solution, what I'm looking for from this particular solution. Okay, now let's move on. Two other things that we need to talk about here. Cloud actors. Cloud consumer, that's people like you and me. We are using cloud. We are the consumers. Cloud providers, this would be your AWS, Azure, Google Cloud. Cloud auditors would be who are assessing the cloud service against a certain criteria. Is it meeting my security requirements? That would be a cloud auditor. Cloud broker would be more to do with if you're talking about managed service, right? So for example, if you have some other provider who's going to be managing your cloud, he's taking responsibility of your cloud at this point. So that is where a managed service provider comes in. They could manage one cloud for you, or you could be managing multiple clouds for you. So think of this as man in the middle. So if you are here as an enterprise and you're trying to use the cloud, this person who's in the middle will be managing the cloud for you, the man in the middle. That is your cloud broker in this case. Okay. Then the cloud carrier, this is again the service provider who's making sure that you have the right connectivity to the cloud. There are certain services that come in like express routes where they're able to give you certain speeds to a certain cloud provider. So if I'm using Microsoft is my go-to service for everything, like I'm using Microsoft Office and some other services like Teams, I want to make sure that I have the fastest connectivity to them so that my latency is low and I'm able to get better performance. Okay, so that's the cloud actors for you. And then you have cloud components. What should I go to cloud for? Again, as you notice, I can go for compute, just compute. I can just go get storage. I can get some network services. These are all virtual NIC, virtual switch, virtual routers. And then you have security. I can also have some, if I don't want my firewall, I can go to the cloud and they can do certain features for me. There is a new term that's been floating around, SSE. Think of this as having a cloud that is running my firewall. So firewall in the cloud kind of a service, you can think of that as. Secure Service Edge is what this is called. And this is what stands for. Some of the companies that are doing is Zscaler name comes to me. This was the first company to start going to the cloud for the firewall services, and now some other features are coming up by the public providers also. And then obviously you can have custom built applications that you can go to the cloud for getting a certain application, right? Now let's look to close this. Like always, what we spoke about was some of the features of the cloud. But again, I'm trying to close this with this idea is a journey to the cloud it's a journey. It's not like tomorrow I decide that, okay, let's go to cloud, and we certainly start moving our stuff to cloud. There has to be a method or a way that I need to follow. First of all, when you're looking at this, you have to understand and identify who is the stakeholder or holders in this case. Is it a one person who's the, say, owner of the company if it's a small company, or if it's a big public company, then is it a board that will approve a certain budget to a certain business unit? All that, right? So just think of this as the person who has the authority, or simply put, has the money to fund the new project. Once I've identified that person and they have told me that, yeah, you know what, we've heard a lot about cloud and this is the direction we want to go, then you move on to a feasibility study where you want to understand, okay, let's understand a gap analysis. What is my current state? Where is the direction I'm heading? And what kind of support do I need in terms of SLA when I'm trying to build my solutions? Once you've done all that, then you try to understand, okay, so what is going to be my benchmark? So this is where I baseline stuff. What kind of performance am I looking from my infrastructure? If I'm running a server, what kind of performance should I look? Or if I'm running an app, what performance am I expecting? How available is it? Always available? How do I respond to an incident that happens? If some breach happens or something fails, how do I fix it? Do I have some sort of compliance, PCI, and all those? What sort of SLA should I use? I can only afford to be down few minutes in a year, or if something happens, I want somebody to fix it right away, or I just cannot afford. So whatever that SLA is, that's kind of where you need to understand the benchmarks. Once you've done that, then you're in a journey to pick the big three, right? So let's say if you're looking at the public cloud, AWS, Azure, Google, which should I pick? Obviously, the decision will make on, okay, do I have some sort of proprietary apps that I'm already running, or can I use some open source technologies that would help me decide which direction should I go? Do I have an existing vendor lock-in? So which means I already have an account with Azure. I'm already doing fair amount of business with them. If I start doing more, I might get better discounts. So this way I'm better off getting with Azure than trying to look at the other two. And then you have to understand, what kind of model should I look at, right? What kind of model should I look? Should I pay as you go, or should I understand and say, okay, let's reserve some stuff? This will depend on how much usage you have of a cloud. That will help you pick up all these options. Once you've picked up that, let's say you decided everything, now you're like, okay, I've done all that, then you have to test it. This is just still a theory that this is going to work. Let's put it to the test. That's where you do your proof of concepts. Once you do your proof of concepts, you need to have some sort of criteria that, okay, when I'm doing this proof of concept, what should I really do in that proof of concept? What check marks are made so that I know that it was success or was a failure, or maybe I thought it would have been successful, but it did not end up. Once you get success based on what you define success to be, then you run a pilot. You still don't want to go all production. You test it out with certain apps, or if you have 100 stores, you put 2 stores to there and see if everything works fine. If it does, then you move to the cloud. It's a journey, so you have to go through all these steps. These are not very, very detailed steps. These are high level steps, but obviously there's much more to them if you start opening each one of them. But I wanted to still give you a framework where to start when you're thinking about cloud, or if somebody's coming to you to say that I want to go to cloud, at least you should be able to tell them, look, these are the steps that you got to take in order to be successful and get to what you want. Thank you.